Okay, so this is the first video over section 3.3 where we are going to be analyzing graphs of quadratic equations, quadratic functions. So there are two forms that we have for any quadratic function, and we're going to talk about those two forms. So this first form should look very familiar to you because this first form is basically the form that you have whenever you are doing something where we were back in 2.5 when we were graphing our transformations. So we know that something inside the parentheses with x, so this value here h that we have, that basically is going to move our graph to the left or the right respectively. Remember, a minus is going to move it to the right and a plus is going to move it to the left. And then this value out here on the end, that is our vertical shift. If that's a plus, as we remember, that's going to move it up. If that is a minus, that is going to move it down. And then the other important piece of this is this value out here that will be in front of that parentheses, which they're denoting with that letter A. Now, we didn't talk about what that does to the graph in terms of stretching or shrinking the graph. However, we did talk about the fact that if that value was negative, that it would make that graph open down, and if it was a positive, that graph would open up. The reason being it would open down because that would reflect it over the x-axis. So if you have a quadratic function that ends up in this form, then you are familiar with all the different pieces that we are going to discuss. So what we're going to talk about is we're going to talk about what makes that parabola open up, which you already know. That value there being positive, it'll open up. Being negative, it will open down. And that is immediately going to tell you whether you have a maximum value or you have a minimum value, which we've talked about in previous chapters as well. The one difference is that instead of calling that a maximum or a minimum value, as you see number 3 down here, we're actually going to call that a fancy word for a quadratic function is that place on your graph where you have that relative max or you have that relative minimum. That value is what we call the vertex. And then every parabola has this line, this vertical line, because it's x equal to a number. So it has this vertical line there that represents the symmetry of that parabola. It won't always be the y-axis, but it will just be whatever that vertical line is that runs right through the vertex. So every time that you graph a quadratic function, you're going to get one of two shapes that you see on this page here. So either you're going to get a parabola that opens up, which means that that value for a was greater than 0, or you're going to get a parabola that opens down, which means that that value for a was negative or less than 0. And again, that different number tells you how wide or how narrow that parabola is, but you're not responsible for that portion of it. But every parabola has a point down here, which is, in this case, if it opens up, that point right there is a relative min. It is a minimum. And again, that's what we're going to call that vertex, which we're using the letters H and K to represent that vertex. And then you have that line that runs right through that vertex, this imaginary line that runs right through that vertex, which represents our axis of symmetry, or what you call line of symmetry. If you hear me say line of symmetry as opposed to axis of symmetry, they mean the same thing. And that is a vertical line, and it runs right through that vertex, and so it's x equal to h. And then we can talk about domain and range, and we can talk about increasing and decreasing, but those are all things that we've talked about previously. So if you have a parabola that opens down, then that point right there will no longer be a minimum, it will now be a maximum. But it is still our vertex. It's still at that h comma k, determined by your shifts, whether it moved it left or right, or whether it moved it up or down. You're going to know where your vertex is immediately. And so that point there, we're going to call that vertex. And again, we still have that axis of symmetry that runs right through that vertex. That is that vertical line x equal h. So that's kind of the main pieces that you have of quadratic functions are the two basic shapes, and then how you find that vertex and how you find that axis of symmetry, and then that value for A telling you whether it opens up or it opens down. So what we're going to look at is we're going to look at the two different forms that you have for quadratic functions. We're going to do a couple examples of this first form here, where basically, if you want to think about in terms of completing the square has already been completed for you. So we're going to look at a couple examples where the square has already been completed for you, and it's just a matter of you remembering your transformations about shifting right, shifting left, shifting up, shifting down, and that value for A telling you whether that parabola opens up or opens down, and then being able to answer all the questions after that. So we're going to do two examples of quadratic functions that are in this form, and then we're going to take a look at the other form. And in the other form, all that is different is that there's just a different way in which we find the vertex. Everything else is the same. You'll still see that value for A, but how we find the vertex becomes a little bit different. And so I'm going to show you two examples of each, and that will come in the next two videos. So in the next video, I'll show you the first two examples of functions in this form, and in the last video, I'll show you the two examples of a quadratic function that are in the other form.